So once again, I've written a few pre-notes just to set up the problems. The law of cosines is an extension of the Pythagorean theorem for not necessarily right triangles. It says z squared is x squared plus y squared minus 2xy cosine of angle that's across from the side that's acting like the hypotenuse. So it's necessary that those things match. If you have side angle side, which you can tell that it's side angle side because you've had an angle, but you don't have a side across from it, and you only have one angle, so you can't find the others yet. So, you set up the law of cosines to find the side that's across from the angle. So that's all one big number. You don't have to solve anything because there's no variables on the right side. You just stuff it into your calculator. And it turns out this is a magic number. C squared is 49. So C is 7. I have a dot there. Silly pen. Okay. Actually, let me get rid of this arrow. Once you have that, you can use the law of cosines again, or you can use the law of sines to figure out one of the angles. There is a problem where the law of sines can't tell if an angle is 91 degrees or 89 degrees, and it will only tell you 89. And so if it's supposed to be bigger than 90 degrees, the law of sines gets screwed up. But you can only have one angle that's bigger than 90, and the smallest one can't be. So I'm going to find angle B this way. I have sine 60 over 7 is sine B over 5. Cross multiplying, you have 7 sine B equals 5 sine 60. So sine B is 5 sine 60 degrees. Don't forget to close parentheses before you divide, over 7. You get a decimal number, and you have to do second sine of whatever that decimal number is. Yeah, maybe I'll just calculate that number for you, just for this once. You'll see. And you get the angle. While I'm doing that, I'll just write it down. It's 38.2 degrees. Okay, what is 5 sine 60 over 7? 5 sine 60, close the parentheses, divided by 7. 0.618. 589. I just do second sign of answer. And then the remaining angle you just get by subtracting. All right, next, I'm going to try and do these in blue so you see what's the given information, what's the new information. One more. Find, again, the angle that's across from, the side that's across from the angle. Okay, R is 26, This is another magic number like the Pythagorean triples. Find the smaller of the remaining two angles. So set up with angle R. Cross multiply. And then divide by 26. Get a decimal number, second sign. And you get an angle. I guess it's 27.8 degrees. I'll do it that way. Okay, next. If you have three sides, pick one. Find the largest side first. The law of cosines can tell you whether an angle is bigger than 90 or not. So little warning. People want to do just the subtraction of the numbers because they see them, but remember 720 is not just a number. We'll have to subtract off. Do you get 0? No, you don't. Remember, cosine of 90 degrees is 0. So z is 90 degrees. Oh, it's a right triangle. 9, 40, 41 is a Pythagorean triple. So we'll do the law of cosines again. So to get another angle. I'm going to do it this way because if you get in the habit of just doing it, you can do it all in one swell swoop. Don't forget there's a negative stuck to the 2 times 40 times 41. So it's the angle, the side across from the x squared minus the other two squareds over negative 2 times the other two. And parentheses around the top and the bottom. Let me get rid of the extraneous parentheses and make that prettier. So if you type that into your calculator, you can type in 9 squared minus 40 squared minus 41 squared, and then divided by parentheses around the bottom once you've found out what the top comes out to. So you get second cosine, you'd get x's that, and then subtraction gives you, Oh, it says round to the nearest tenth, so I'm going to round to the nearest tenth. Okay. Next. Pick one. B actually comes out more than 100 degrees, more than 90 degrees, more than 100. Pick another one. Again, the order that I do it in is I figure out 7 squared minus 6 squared minus 10 squared. And then I divide by negative 2 times 6 times 7 times 10. Just don't forget, if you type all of that in at once, you get a, you have to make sure you put parentheses around it or turn it into negative 120. And you get okay, and then the remaining angle is I'm not getting a total of 100 exactly. Well, round off error, whatever. Okay, next. Again, if you have an angle, find the side across from it first. And again, that's all one number. Take its square root. Ugh, let me get rid of the arrow first. Okay. Find the smaller of the two angles. And in fact, P comes out to, and Q was bigger than 100, bigger than a 90-degree angle. So you would have gotten a wrong answer if you tried to do law of sines to find angle Q. Okay. Just to drive that into the ground. I'm not going to elaborate it anymore. 12.001. You don't have to worry about the law of sines if you already have an angle bigger than 90, because the second one can't be. So, but we'll find the smaller one anyway. It's a good habit. Cross multiply, divide by 12, take the second sign. Subtract from 180. And you get your stuff. Okay, so the trick to these is we're going to find, if we have, let's see, AB is, and just draw it like this. AB is 8, BD is 10, or sorry, 7, DC is 5, and AC is 10. Then I'm going to try and figure out AD, which I'm just going to call side B. The trick is find this angle first. So B is across from the 10, and the total on the other side is 12. So yeah, 10 squared minus 8 squared minus 12 squared. Don't forget to divide by a negative. Angle B is 55.771 degrees. And then once I know angle B, I can go use a side angle side thing. Incidentally, since it's cosine twice, there is a little bit of thing you can do. You can just say cosine B figure out that number and plug it in for cosine of B. Regardless, you get B, which is AD, is 7.07. Okay, setting up the same thing. AB is 5, D is 5, 3, 7, angle B. Go across from B first. Okay, B turns out to be exactly 60 degrees. And then you look at the smaller version to find AD. Oh, B is 5. It's a miracle. It's an equilateral triangle. Because you got two sides that are 5, so it's isosceles, and there's a 60, and that means that there's 120 left between the two isosceles angles. So there you go. Okay, to do this problem, I'm going to draw two different diagonals on the parallelogram, and I'm going to find them separately. First one, we'll draw the easier one, which is, I guess, the shorter one. So okay, and then we'll draw the same parallelogram, but with the other, the long diagonal, which I think I'll call C. Six. Oh no, what's the cosine of? Yes, we can find this angle. So the thing about a parallelogram, of course, is that the two angles that are next to each other are supplementary. So if this is 70, this is 180 minus 70, which is 110. And again, it's all one big number on the right side. Take the square root. And you're done. All right, it just says find AB, so use the other two legs. Don't forget to take the square root. Almost 21. Not too bad.